Today we're going to finally put everything together. I know we've seen some quadratic equations where if we have a negative inside of a square root, we just say there's no real solution, but now we're going to go ahead and find the solution including the imaginary numbers. So just to review, we have that this right here, the square root of -1, is really going to be defined as I. Oops, not square root of I, but I. Okay, in other words, if you see a negative inside a square root, that's just going to make your answers imaginary. So for example, let's say I have the square root of -8. Okay, the way you would write this is that it's the same as -1 times 8. And so the square root of 8 we know reduces to 2 root 2. And then all we're left with is the square root of -1. So whenever you see a number that's negative on the inside, you reduce the number or take the square root like normal, and then the negative on the inside, which is really a -1, means you just attach an I to your answer. Okay, so that's kind of how the imaginary numbers work. Again, the definition comes from the square root of -1. Okay, so let's write that down here. I is defined to be the square root of -1. However, we will never typically write the square root of -1. We'll just leave it as I. Okay, and then here we have a quick little powers to figure out for I. Okay, I squared. If you remember what exponents mean, when you have a square, you multiply this number times itself. So if you take the square root of -1 times the square root of -1, the square roots cancel out, okay, and then you just get -1. Okay, I cubed, well, that's just I squared times I, and since I squared is -1, then this is really going to be -I. Okay, and then you can kind of play this game all throughout. I to the 4 is the same as I squared times I squared, which is just -1 times -1. In other words, that's +1. Okay, now if I go back to I to the 5, I to the 5 is the same as I to the 4 times I to the 1st, but we just figured out that I to the 4 is actually 1, so 1 times I is just going to be I. And what's going to happen, so you're going to see this pattern, that's why we have things grouped in 4s like this, that just repeats. I, -1, -I, 1, and so on. Okay, now in general, let's say we have a larger number, like I to the 33rd, okay? And we don't know where in the pattern we are. What I always say that you can do is break this down into I squared and then figure out how many times 2 goes into 33 evenly without a remainder. I know that 2 times 16 makes 32. Since this is 33, I put in an extra I. Okay, so in other words, 2 goes into 33 16 times, but that only makes 32. To make a total of 33 i's, we put an extra I there. And now we know that this is -1 to the 16th power times I. And I know that a negative to an even power, like a negative squared or negative to the 4th or to the 16th in this case, that just becomes +1. And then 1 times I is obviously I. So that's kind of how you can do this without memorizing the pattern. As long as you know two things, that the definition for I is the square root of -1, but probably the most important is that whenever you see I squared, that automatically gets replaced with a -1. Okay, so this one right here, that's probably the most important out of all these, and then as long as you know this, you can figure everything else out. Okay. Now, I also should mention, since you'll have a calculator available, that you could type some things into the calculator to figure this out. So for example, right here, if you look right above the decimal point in blue is the imaginary number I. So if you type second and then hit the dot or the decimal point, you could type in what we're working on. Let's see what it says. And so here I get negative 3e minus 13 plus I. So now remember, when you see this notation, okay, this part of it right here, everything before the I, that actually is 0. It's just your calculator has a hard time with larger exponents. Because remember that the negative 13 is scientific notation here, which means that we're going to move this decimal point after the 3 over 13 times. So this is essentially negative 0.000000 and so on. Or in other words, it's just 0. So if this is 0 plus I, our calculator is also telling us that our answer is going to be I, like we got here. Okay. Let's see, for smaller numbers, I think it's probably all right, like I to the 9. Oh no, it still does that. So it's good to know how to do this by hand. If you're going to use the calculator, you have to remember this part here is 0. So again, the answer is I. Okay. Let's see if I did I to the 8, which we already figured out. Okay. So this is now 1 minus, and then this part here is 0. So it's saying 1 minus 0i. In other words, it's just 1, which is what we have here. Okay? So the calculator is a little goofy with that, but it is possible to use a calculator to figure some of these powers out. Okay? Now, as far as dealing with these, you're going to do addition and subtraction with imaginary numbers and multiplication with complex numbers in the same fashion that you would regular problems, like if these were x's. You still combine like terms, you still do everything the same way, it's just now it's an I. All your answers are going to always be written in what we say a standard form. You have the real part of the answer and then plus the imaginary part of the answer. Okay, so that's what we're shooting for with all of these. Okay, so here, if we just distribute the negative, like normal, right? We get negative 10 minus 9i. Now we combine like terms. The real numbers, 2 minus 10 give us negative 8. And then minus 5i and minus 9i give us minus 14i. So there's our answer. It's just combining like terms. And again, if we check on the calculator, you can just type it in exactly the way you see it. 2 minus 5i minus 10, don't forget the parentheses, plus 9i. And we get exactly the same answer. Okay, so the calculator is actually pretty useful for these multiplying, adding, and subtracting problems because the exponents for I don't get large like they do up here. Okay, so let's try this one by hand. In fact, I'll do everything by hand now that you know how to do the calculator, because a lot of times doing it by hand is quicker if you know what you're doing. Okay, so distribute. This becomes 4i minus 14, and then I times I is I squared. Now, like I said above, anytime you see I squared, that automatically becomes a negative 1. So it's really negative 14 times negative 1. And so the real part of this is this term. The negative times a negative makes it positive 14. And then this positive 4i is the imaginary part. Okay? Now in MATLAB, I'm not sure how strict they are with writing things in this order. I would always stick to this. However, on a quiz or a test, if you wrote your answer as 4i plus 14, that would be okay with me too. Okay? All right, let's do this one now. So, and you know, what might be good practice for you guys, especially if you're watching this at home, pause the video before I do these examples and see if you can get the same answers I do. And then if you don't, you know, you can watch the explanation or my steps and see where you went wrong. I think that'll be pretty useful. All right, so I'm going to do this one now. 2 times 2 is 4. 2 times I is 2i. And now I distribute this negative 6i to the 2, and I get minus 12i. And then minus 6i times I is minus 6, but I times I is I squared. And now, again, I squared is really negative 1. So this 4 is going to get combined with this negative 6 times negative 1, which is a positive 6. So that's going to make 10. And then 2 minus 12i is negative 10i. So your answer is 10 minus 10i. Okay? This one, hopefully you see the pattern, but if not, you still do the usual FOIL or double distribute, whatever you want to call it. Negative 8 times negative 8 is 64. Negative 8 times negative I is positive 8i. And now on the inner part, you get negative 8i. And then I times negative I is negative I squared. Again, I squared is negative 1. Subtracting a negative 1 is really adding 1. So this 64 plus 1 becomes 65. And then you can combine the like terms here and cancel these out. So we just get 65 in this case. Okay? All right, so now putting all this stuff together. So in addition to adding and subtracting and multiplying, now we got to apply what we've learned to quadratics. Okay, so here's a quadratic equation. It's already set to 0. You notice that there is no other x term except this x squared, which means that we could just solve by moving things around. So if you subtract 16 and then square root both sides, now you're going to get x equals plus or minus. And before, if we saw a negative inside of a radical, we would say, well, that's not possible. It's not real. It's true, but now we're extending our answers to include complex numbers. So we're going to follow the rules with the i's that we just talked about. I know the square root of 16 is just 4. The negative on the inside, again, just means essentially you attach an I to your answer. So we have x equals plus or minus 4i. Okay, let's try this one. This one looks like we can factor it. Or at least I'm going to try to factor it. Let's see. If I do 2x, 5x, this is going to have to be a 1 and a 1 either way. That's not going to work. If I do 10 and 1, that's not, actually I don't think this factors at all. Okay, so since this doesn't factor, we're going to use the quadratic formula. Okay, so the quadratic formula says that x equals the opposite of b, which in this case is negative 6, plus or minus the square root of b squared, so that's 36, minus 4 times a is 10, and let's see, b squared minus 4 times a times c is 1. This is all over 2 times a, which is 10. Pen is kind of dying there, so we can switch again. Now we just simplify like usual. So negative 6 plus or minus 36 minus 40 becomes negative 4. And now 2 times 10 is 20. And now I reduce negative 6 plus or minus the square root of negative 4. Just reduce this like normal. The square root of 4 is 2. The fact that there's a negative in there means it's imaginary. That's all divided by 20. Okay, and then from here, there's lots of ways to do this. I think the easiest way, if you see common factors among all three of these, so 6, 2, and 20, I know all of those you can divide by 2. That's probably the fastest way to do it, but you have to divide every single one of those three numbers by by that GCF. So if I divide negative 6 by 2, I get negative 3. The 2 divided by 2 becomes just a 1, so it's just I. And then 20 divided by 2 is 10. So this would be fine. You might, on MathXL or MATLAB, I mean, you might have to split your answers up into 2, so like negative 3/10 plus, this would be the same as 1/10 I would be one answer, and then negative 3/10 minus 1/10 I would be the second answer if they ask you to split it up like that. Okay? All right. Now the second one is the difference of cubes. Okay? So I know that I could add and then cube root it, but we're only going to get one answer doing it that way. So we're going to factor using the difference of cubes formula, which if you forgot, anytime you have x cubed minus y cubed, the pattern for factoring the difference of two cubes like this is the first factor is x minus y, and then the second factor is x squared plus x times y, and then plus y squared. Okay, so this is the pattern that we use to factor. Now here's how it would work in this context. So here I identify that it's really x cubed minus 2 cubed. That's how we get 8, because 2 to the third power is 8. And now I just follow this pattern. So this would be the same as x minus 2, because it's x to the third and 2 to the cube, 2 to the third. And now you just follow this. So here we do this squared, so x squared plus this number x times that number, which is a 2, so that's 2x, plus this number here, which is 2 squared, which is 4. Okay, so right now I get x equals 2 if I set it equal to 0. That's one answer. And then in here is where we're going to get the other two answers. Okay, so if we use the quadratic formula, again, x equals the opposite of b plus or minus the square root of b squared. So that's 4 minus 4 times a times c. That's going to give us 16 all over 2 times a, which is 2. Now we're going to get negative 2 plus or minus. This reduces to the square root of negative 12. And now again we reduce that like normal. I know that the root of 12 is the same as 2 root 3. Since it's a negative in there, it's just I at the end. That's all divided by 2. And then the final step, every single one of these three numbers is divisible by 2. They're all 2s. So if you divide every one of those by 2, you get negative 1 plus or minus root 3i all over 1, or just negative 1 plus or minus root 3i. So your three answers are x equals 2, and then negative 1 plus root 3i, and negative 1 minus root 3i. So if you have to split them up, that's how you would do it. Okay? All right, so that's the end of the lesson for complex numbers and solving quadratic equations using them. You should be able to now complete the 1.3 MATLAB homework. All right, thanks. Have a good day.